Okay, I just wanted to go over some of the things that are going to be on our test, section 4.1 through 4.3. You need to make sure that you can label all the parts of the coordinate plane. Label the origin, the x-axis. Let's see, the origin is located right in the center. The x-axis is the horizontal line. The y-axis is the vertical. Quadrant 1 is the upper right corner. Quadrant 2 is the upper left. Quadrant 3 is the bottom left. And quadrant 4 is the bottom right. So make sure that you can label or identify each of those points. So let's look at some of the examples. You've got to be able to write an ordered pair that corresponds to a given point. So for point A, I'm going to look and I see it's -3. Okay, it's +2. Looks like one of my points have disappeared when I copied. So it's a point -3, +2. Now point B is -1, -2. Point C is 2 over 2 up 0, so that's a point 20. And point D is 1, 2 up to 3. So to the right, +2 up 3. Now another thing you need to do is you need to be able to plot and label ordered pairs in the coordinate plane. So for this one, I've got A is the point 0, 3. So I go 0 on the x-axis and then up 3. 1, 2, 3. So you put the point and label it as A. B is the point -2, -1. Plot the point and label. C is the point 2, 0. 1, 2, and then up 0. That's all there is to that. Those are going to be 2 points each. Okay, now I may ask you to list a point that's located in a particular quadrant. So list a point that's located in quadrant 3. Now with quadrant 3, I know 1, 2, 3, it's right here. So I know my x values are negative, my y values are negative, so I can list any point like -2, -2. That's a point that's located in quadrant 3. Okay, now list a point that's not located in a quadrant. Any ordered pair that has a 0 in it. So the point 0, 0 is not located in a quadrant. The point 0, 2 or the point 3, 0. Next, rewrite the equation in function form. That just means rewrite it where y is all by itself. You're not really solving it, you're just isolating y. So now I'm going to subtract 3x from both sides. So that cancels out. Now I'm left with 2y is equal to 7 minus 3x. I cannot combine 7 and 3x because they are not like terms. 2 is still not by itself. I'm going to divide both sides by 2. So now I have y is equal to 7 over 2 minus 3/2 x, and this is my final answer. Now I have 2x plus 6y is equal to 6. And again, I'm solving for y, or I'm isolating y. So I'm going to subtract 2x from both sides. So now I have 6y is equal to -2x plus 6. Well, now I need to divide by what? By 6. Divide each term by 6. Oh, I'm going to be able to simplify this time. So now I have y is equal to, -2 over 6. That simplifies down to -1/3 x plus 6 divided by 6 is 1. So I have y is equal to negative 1/3 x plus 1. Okay, graph the following line using a table. Remember, our x values, we can choose whatever we want. So I have the equation. It's already solved for y for me, so I've got y is equal to 1/2 x plus 3. I'm going to be careful when I choose my x values because I want this 2 to cancel out. How am I going to make that happen? Multiples of 2. So I'm going to start with negative 2, then I'm going to do 0, and then I'm going to do positive 2. So now I have y is equal to 1/2, plug in my negative 2, plus 3. 1/2 times negative 2 gives me negative 1. Negative 1 plus 3 is going to give me 2. So now I have the point negative 2, positive 2. Now I have y is equal to 1/2 times 0 plus 3. I love 0 because 0 is like a magician. 1/2 times 0 disappears. So now I have 0 plus 3 gives me 3. Now I have 2. Y is equal to 1/2 times 2 plus 3. Oh, those 2's cancel. What's 1 plus 3? 4. Notice my pattern. Finish writing all my little points. I've got the point 0, 3. X value 0. My y value is 3. And the point 2, comma 4. Now I'm just going to go plot these guys. So 1, 2, 1, 2, 3, 4. 0, 3. And negative 2, positive 2. So now when I connect these lines, these points, it's going to make one nice line. Okay, find the x and y intercept and graph the line. This is just like the homework from section 4.3. Remember, I want you to go ahead and label it. So my x-intercept, I'm going to let y is equal to 0. So I'm going to say, okay, I've got 2x plus 4y is equal to 16. 2x plus 4 times 0 for y is equal to 16. 2x is equal to 16. Going to divide by 2. So x is equal to 8. So that gives me the coordinate of 8, 0. I'm going to make this a scale of 2 because I don't have a big enough grid. 2, 4, 6, 8, up 0. Now let's do the next one. I'm going to do the y-intercept, and I'm going to let x equal 0. So I have 2 times 0 plus 4y is equal to 16. 2 times 0 is 0. So I have 4y is equal to 16. I'm going to divide both sides by 4. So y is equal to 4. What are my coordinates for this one? Oh, x is 0. Y is 4. 1, 2, 4. Go ahead and keep my scale. Sketch my points and I'm done. Now number 8, we're going to look at the graph and determine the x and y intercepts. Okay, now I'm going to look at the graph and determine the x and y intercepts. So first I'm going to look on the x-axis. I'm going to see what this point is where it crosses the x-axis. It's negative 1, 2, 3, 0. X-intercept is the point negative 3, 0. Now the y-intercept, let's see what it is. It looks like it's about right here. So it's a 0, 1, 2, 3. So it's a point 0, 3. So these I just find by looking at the graph. Okay, now draw a scatter plot of the data provided. Remember to label your graph. So I'll look at what I've got. I've got my time and then my temperature. We're going to put the time on my x-axis. I'm going to put the temperature on my y-axis. Look at the time, 1, 3, 5, 7. I'm going to go by ones. So I'm going to have 1, 2, 3, 5, and 7. And I'm only going to write every other number. Now my temperature goes from 63 up to 74. I'm going to put a break in my graph. And I think I'm going to start at 62. And then maybe go by twos. So I've got 62, 64. I'm not going to write it just so my graph won't be too crowded. And then 66, 68, 70, 72, and then right here 74. Now I'm going to go and plot my points. 1 and 71. See, there's 70. 71 should be about right there. 3 and 74. 3 and 74. 5 and 68. 7 and 63. Okay, this gives me a much better representation of what happens to the temperature over time. So the temperature increases from 1 o'clock to 3 o'clock, and then from 3 to 7, it decreases rather drastically. Now this last problem that's on here, verifying solutions, this is something that you already know how to do. So if I look at the point 2, negative 1, 1, 2, negative 1, it looks like it's on the graph, but I want to verify if it's on the graph or not. So I would say, okay, 2 is x, negative 1 is y. So I've got 3x minus 4y is equal to 10. So now I'm going to verify algebraically. So I'm just going to plug those values in. So I have 3 times 2 minus 4 times negative 1. And I'm hoping that's 10. So I have 6 minus negative 4. Double negative is a positive, so that turns into 6 plus 4. And 6 plus 4 gives me 10. So the point 2, negative 1 is a solution. It does fall on the line. Now those special graphs we've talked about, if I want to graph x equals 2, I'm going to go on my x-axis and I'm going to go to 2. I'm going to put my point, and I want to draw a line that will only go through 2. I don't want it to go through the y-axis at all. So that line is going to be vertical. It's going to be parallel to our y-axis. And that's one of those special lines. Now y is equal to negative 5. I'm going to go negative 5, 1, 2, 3, 4, 5. Draw my little circle. Now I'm going to draw a line that only goes through y at negative 5 and doesn't go through anything else. Okay, so please remember to review your homework, watch the other videos if anything's giving you any trouble, and look forward to grading some really good tests.